Hello, everybody. My name is Cameron Snow, and I'm a geologist and petrophysicist that's been working in the oil and gas industry for about 20 years. During my career, I've had two areas of interest. The first is petrophysics, where I focus on calculating and quantifying reservoir properties to give everyone a better understanding of the oil and gas in place in a play or a field. The second is the application of geological risking to exploration drilling. That's what I'm going to be focused on in this video series. During this series, I'm going to start with some of the basics on geological risking. What is it? Why is it important? And I'm going to build up the concepts until we have a more comprehensive understanding of how we can perform a geological risk assessment and use that to get a better understanding of the risk and reward available to our companies within a portfolio. I'm going to start with the very basics in this video. And the most basic question is, what is geological risking? So if you work in exploration, a lot of times you'll hear something like, this prospect has a 40% chance of success, or P sub G. Um, Now, from a statistics point of view, it's very easy to understand that. Okay, there's a 40% chance of success. That means 4 out of 10 times we would expect there to be a discovery. We would expect oil and gas to be present. But what goes into that number? Well, when we perform a geological risk assessment and we come up with that 40% chance of success, what we've actually done is we've actually gone through and evaluated what's the likelihood that each key hydrocarbon system component is present. So, for example, maybe we have evaluated the seismic survey over an area and we've said, okay, there's a 90% chance that there is a suitable structural trap. And then, we analyzed our environment of deposition and we said, okay, there's a 85% likelihood that that sandstones are present and that there's a 90% chance that those sandstones have good reservoir properties that will allow us to flow oil and gas, and so on and so on. So that is how we build up a risk assessment. And don't worry, we'll go into this in more detail as we go through this series, and we'll make sure you have a good understanding of this process. The second part of performing this geological risk assessment, which is often something that people don't think about, is determining the range of volumetric outcomes. And I say the range of volumetric outcomes for a reason. And that's because it's very rare that we can actually say with certainty what the volumes will be. And that's due to a number of reasons. So first of all, in exploration plays, we often don't have a lot of data. And so, we may make an assessment like, oh, the area of this prospect is somewhere between 500 and 1,000 acres with respect to the size of the closure. And the thickness of the reservoir can be between 20 and 40 feet, and the porosity can be between 15 and 25%, and so on and so on. And we use that to calculate a range of volumetric outcomes. And the final part of the assessment is we combine the risk and the volume to come out with risked volumetrics. So we want this risk assessment of the potential outcomes. And doing this in a consistent and data-driven manner is what is critical. And that's what we're going to be building up to throughout this video series. Now, one thing that I want to emphasize is risk is not a property of the reservoir. It's an interpretation, it is a number that we assign, but it is not real. It's not something where we can go to the well site and measure it. I can't hand you a sample of rock and ask you to measure it in a lab. Risk is a concept. So that's important to understand. It's also important to understand that risk is really a pre-drill concept. So we assign risk before we drill the well, and then after we drill the well, we know the answer. I like to think about this with respect to if I were to hand you some dice and I said, all right, I want you to roll one dice and I want you to tell me what is the likelihood that it will be a 3. Well, you would look at it and you'd say, well, this dice has 6 sides, one of them is a 3, so there's a 1 out of 6 chance of rolling a 3. But once you roll the dice, it is either 3 or not 3. There is no in between. And it's very much this way for understanding geological risking. Now, there may be other questions, such as how much will the well produce, how much, what will the rate be, what are the economics? Those are all subsequent questions. This is focused on the pre-drill. So that's a long way of saying that risk is it's kind of a construct of our opinions and beliefs about the subsurface, that we try to base on a combination of our experience and the data that's available to give us some estimate of what the likelihood that we encounter oil and gas will be. Now, I think the best way to really lock in the understanding of what geological risking is to think about it in terms of the hydrocarbon system and a basic well that we may drill. So if we look at this block diagram here, we have this oil well that we would like to drill. So what are the key components here? Well, the first question is, what's our structural trap? Okay. The second is, what is our seal? So, okay, we've got this structural trap, we've got a high area, we've got an impermeable clay layer above us, what's our top seal, our cross fault seal? Is the reservoir present? So what do we know about the environment of deposition and the presence of reservoir and offset wells? What's the likelihood that it's going to have high quality reservoir capable of flowing oil and gas? What is the source rock, and is that source rock mature? And is there a pathway for hydrocarbons to get out of that source rock and into our reservoir? So we want to identify each of the parts of our hydrocarbon system, and then we want to assign a likelihood of success. And we do that in a construct similar to this. So what is the probability of there being structure? What's the likelihood of sill, the likelihood of reservoir presence and deliverability, and so on and so on. And then we, multiply those together, we take the product, and we come up with a 42% chance of success. All right, that's not that hard, right? All of you are capable of doing that math. And so, then you calculate some volumetrics on that prospect, and let's say it comes out to 300 million barrels of oil in place. And then you're ambitious and you run off and you tell the CEO, hey, we have a 42% chance of getting 300 million barrels. And the CEO says, oh, that's great. Let's go drill this well. Well, unfortunately, you didn't do all the work, and what you told the boss wasn't accurate. And when you come back and you've only got 30 million barrels, now you've got to explain to the CEO why you got that wrong. And what I hope to cover in this video series is I hope to cover the background material that will allow you to avoid making this type of mistake. So we're going to give you the tools not only to calculate the probability and the risk volumetrics, but also how to communicate what the chance of success is and what the range of volumetric outcomes are. All right, I hope this was a useful introduction to what is geological risking. And in the next video, we're going to talk about why geological risking is important. Thank you.